in this video, we'll talk about our objects. We'll start by discussing what we mean by atomic vectors. There are different types of atomic vectors, including doubles, integers, characters, logicals, complex, and raw vectors. We will also talk about matrices and arrays. And in that context, we will be talking about different types of attributes of vectors, the class of the various R objects, and we'll talk about how do we coerce a vector, one type of vector into another type of vector. And finally, we'll talk about how do we create lists and data frames in R. So let's begin with talking about atomic vectors in general. An atomic vector is just a simple vector of data. And in this vector, we store values as a one-dimensional object. Each atomic vector can only store one type of data, but you can save different types of data in R by using different types of atomic vectors. So here is an example. In this example, we are creating, this is something you're familiar with, we are creating an R object or an R or a vector, which is called die. And this is composed of values from 1 through 6, right? So this is like a virtual die that we created. And there's another vector we are creating, which is called 0, and it takes the value of 0, right? So here are two different types of vectors. The command is.vector tests whether an object is an atomic vector or not. It returns the value of true if the object is an atomic vector and false otherwise. So let's take a look at how this would act on the vector die. So if we use the command is.vector on die, it tells us true, which means that die is an atomic vector. We can also use the function length to return the length of an atomic vector. So in this case, it's telling us how many observations are there in the atomic vector die. And similarly, if we applied length to 0, the 0 vector, it's going to tell us that it only has one observation or one element. So let's talk about the 6 different types of atomic vectors in R. The first type is called doubles. A double vector is really a more fancy word to say that this is a numeric vector. A double vector can store regular numbers, whether positive or negative, including numbers that are decimals. And at any point in R, you can ask R what type of object an object is with the command type of, okay? The only sort of, I guess this is just a naming convention, but our functions refer to doubles as numerics. So this is just, in computer science, they say doubles, and in data science, we are more familiar with numeric, but it's just good to know both, that die is this vector. And then when we look at, if you want to find out what type of object it is, that is a double, right? So this is the output here, double. Okay, so let's move on to integers. As you know, integer vectors store integers that are just numbers without a decimal component, right? So you can think about integers as a subset of doubles, but these can be stored separately in R, and R can identify objects as integers. You can create an R object as an integer by typing a number followed by an uppercase L. So notice here in our example, we are creating an integer vector called int, and this vector has 3 values, 100, 200, and -300. And notice the capital or uppercase L attached to these numbers. So when we look at what type of object is this object int, it's telling us that that's an integer. And that's only because of these L's that are attached to these numbers. Okay, so moving on, the third type of our object, or sorry, atomic vector is a character vector, and this stores small pieces of text. So you can think about, here's an example, you can very easily create a character vector or a string of characters if you surround those by quotes. Okay, so here let's see the example. We are creating a vector, a character vector called hello, and that has different types of hellos in different languages. So hola, namaste, marhaba, ciao, etc. And notice that each of these text or characters are inside quotes, okay, and they are separated by a comma. So just like what you would do to create a regular vector, you would do the same thing. The only difference is that here you have quotes around each element of that character vector. So if we want to look at the type of object that hello is, then we can see that R returns character. Okay. Similarly, if we created one, oops, let's go back. If we created one, which is just, it takes the value of one, but then we put one in quotes. And if we try to ask R the type of object that one is, it's going to return character because this is in quotes. Okay, we'll move on to the fourth type of atomic vector in R, which is a logical vector. A logical vector store trues or falses, and that's just R's form of storing Boolean data. And these are very helpful, which we will see later in the class, for doing different types of comparisons. If you type true or false in capital letters without the quotes that we described for character vectors, R will read your input as logical data. Okay, so you can also just write capital T or capital F instead of spelling this whole thing out. And you don't need to ever put quotes for this, because R reads it automatically. By default, it reads true in capitals or false in capitals as a logical vector. So here we are creating a vector called logic, and this is composed of three elements: true, false, and true. And then when we look at type of what type of vector is logic, it returns, R returns the output here, and it says logical. Okay, so we'll try to see how we can leverage this type of a vector for different types of functions that we want to do when we do data analysis. Okay, the fifth type of atomic vector is a complex vector which stores complex numbers. And you can create very easily a complex vector by adding an imaginary term with the number, to a number with the letter I in lowercase, right? So here we are creating a vector called complex, and this has three elements. The first element is 1 plus 1i. The second element is 1 plus 2i. The third element is 1 plus 3i. And when we look at the type of vector that complex is, R returns complex, right? So we may not be using this too much. In fact, probably not, but you should still know this. And then finally, there are raw vectors that store raw bytes of data. Again, we won't be making too much use of this, but you should just know that these are also types of atomic vectors. But to make a raw vector of any length n, you can use the raw function in R. And so here we are creating a raw function, and this has a length of 4. And so here you can see that this is what it looks like. And then when you say type of, what is the type of raw of length 4, it returns raw. Okay, so that's about the 6 types of atomic vectors in R. Now let's get to talking about attributes. So an attribute is a piece of information that you can attach to an atomic vector or any R object for that matter. So you can think about this as some kind of metadata that's attached to the object or to some kind of vector that you have created. The important thing to remember is that when you attach attributes to an R object, that does not affect any of the values in the object itself. Okay, so if there are no attributes to an object, then it will return a value of null, like, a null set, which is nothing. There are different types of attributes that can be attached to different types of R objects, and the most common ones are names, dimensions, which we will denote by dim, and classes. Okay, so right now, if you remember what we had done before with the die vector, and the die vector was just numbers from 1 through 6. If we want to look at the attributes of die, we can use the attributes command here, or the function, and that returns a value of null. That means that for those values from 1 through 6, there were no attributes attached. Okay, so when it returns null, null is just telling us that that's an empty object, and this is often returned by functions whose values are undefined. You can always create a null object by typing null in capital letters, right? So if you want to create a vector called nothing, and that should just be an empty object, we can say that assign the value of null to nothing. And then when we look at the type of nothing, it just says that this is a null object. So this is one type of object. I mean, mostly you're going to have a lot of data in your homeworks and in your assignments. So you're not going to have this, but we'll see if there are any uses for this later on. So let's move on to something that's more meaningful, which is the names. So one type of attribute is names, and you can always assign that to a particular vector. So if we wanted to find out if there were any names given to the different elements of the vector die, because we already know that there was no attribute assigned, it returns the value of null or output of null. However, we can give it a name or names using a character vector. Okay, so here we can say names of die take these values. Okay, so here you can see that on the right side you have a character vector which has these strings, right? So 1 refers to the first element of die, 2 refers to the second, right? So we're just giving it names and attaching some meaning to it. And then when we look at the names, use this function again on die, it returns basically what this was. Okay. So here are other things we can do. So if you can get the names by just doing names or typing names on die, or you can just you can also call attributes of die, which is sort of more generic. And here it says R returns some output, and it tells you that one of the attributes for die is names, and these are the values that it takes. Okay, now it's possible that you're working with some data and you want to attach some meaning to things, so you at some point may want to change the names or some kind of attribute that's attached to your data. So you want to change that metadata, and you can always just rewrite that same function, names, and then change the character vector, for example, that's associated with it. So in this case, Maybe we don't want to write the names in English and we want to write that in Spanish. So here you're seeing that uno, dos, tres are written here. Okay, and at any point you could also remove the names of names or the names attribute or any other type of attribute by assigning the names of die to null. Okay, so in this case, we're only removing the names attribute. And we are actually making use of the null function, so it's not as useless as we thought. Okay, so the other type of attribute we're going to talk about is called dimensions. And with dimensions, you can transform an atomic vector into an n-dimensional array by giving it a dimensions attribute with the command dim. So we can set the dim attribute to a numeric vector of length n. Okay, we'll see how that works. And what that does is R will reorganize the elements of the vector into n dimensions. Okay, so let's say we know that die is a virtual die, takes the values 1 through 6, and we want to reorganize that die into a 2 by 3 matrix, right? So we want to have always the first number is corresponding to the number of rows, and the second number here is corresponding to the number of columns, right? So we want to arrange the numbers 1 through 6 into 2 rows and 3 columns. Okay, so how do we do that? We can say dim, which stands for dimensions. So dim on die, right? That is a vector with 2 rows and 3 columns. Okay, so now it's very important in R, every time you're doing something, you write a command, you must see what the output is. Okay, so here we're going to try to see what does this do to the vector die. Okay, so does it reorganize the data in a different format? So we see that die now becomes this type of this is a type of a sort of a matrix now, which takes the values 1, 2, 3, 4, 5, 6, and they are organized in some way. So you can see that there are 2 rows, right? This is the first row, and this is the second row, and there are 3 columns: first, second, and third. The important thing to notice here is that whenever R is going to reorganize any vector into a matrix, when you're using dimensions or dim, it is going to go column wise when it fills up the numbers, right? So it's going from 1 through 6, but it's going column wise. So it's going to fill up the column, then it moves on to the next column. So 1 and 2 go into the first column, 3 and 4 into the second column, and 5 and 6 into the third column. So you can see, well, maybe this is, it could be restrictive. Okay, so that's why we move on to talking about matrices. So matrices, as you know, they store values into a 2-dimensional array. And to create a matrix, you can use the matrix function to basically use an atomic vector and reorganize that into a matrix. So how do we do that? Let's say we wanted to create a matrix with the same die, that virtual die that we have, and we want to only have 2 rows in the matrix, right? So we can assign that matrix a name. So we are just going to call it M. And again, notice that by default, if we use this way, it's going to do the same thing as the previous slide, where again, the numbers get populated by column, right? So you first fill out 1 and 2, then 3 and 4, and then 5 and 6 in the last column. Okay, so that's what's going on. But you can control this. You can control how these numbers get filled up. If you don't like those to be filled up by column, you can use the by row argument So the by row argument goes into these parentheses right after you have specified the number of rows. You insert a comma and you say by row equals true. And what that does is it's going to fill up the matrix by row. So it's going to go row wise, and therefore you're going to see 1, 2, and 3 appearing on the in the first row, followed by 4, 5, and 6 in the second row. Okay, so that's pretty much it with matrices. So let's move on to arrays. Arrays are, the array function can create an n-dimensional array. All right, so here we are not going to make use of more than 2 dimensions generally. So it's not going to be something that you're going to see in many applications for now. But it's just good to know that an array is an n-dimensional object versus a matrix is a 2-dimensional object. Okay, and an array is not as customizable as a matrix and basically does the same thing as setting the dimensions attribute. To use array, you can again provide an atomic vector as the first argument and then a vector of dimensions as the second argument called dimensions. Okay, so let's see how we can create. So we are creating R, which is what we are calling the array, and we are using the array function, and the first argument is some data that we are providing, right? So it takes the value 1 through 4 and 5 through 8, and then we are saying organize this data into 2 rows and 4 columns. So it's nice if you can try this out on your own and try to predict what R will do and how those numbers will be filled up. But you can see that by default, R fills up the numbers column wise or the data column wise. So you can see that it's 1, 2, then 3, 4, and so on and so forth. Okay, the next thing we'll talk about is something similar to type of, which is what we saw earlier. So when you change the dimensions of your object, that will not change the type of object, but it will change the class attribute of an object. Okay, so let's try to see an example. So let's see here, what type of object is die. We know this from before that this is a double. And then we can also check what the class of die is. And in this case, the class of die is a matrix or an array. Right? So you can take a look at that. And then, if you try to use class on maybe a character or some kind of text data, then it'll return character for that, right? So that's sort of similar to the character, the type of object, which was character earlier. So even the class is character. And then we can also look at what is the class of, let's say, the number -100. And that returns numeric, right? So that's more intuitive because -100 is a number and it returns numeric, which, if we were to do type of, then it would say double. Okay, so that's about class. And now moving on to dates and times, I think we won't make much use of it right now, but I think you should know that there is an attribute system in R that can represent other types of data as well. So time sometimes can look like a character, but it actually is a numeric or is double. And it has 2 types of classes, POSIX CT and POSIX T. And so you can try this out in R if you want to generate what the system time is. In R, you can say, well, let's assign system.time, sys.time to an object called now, and then you can try to see what now is. So for everybody who's watching the video, obviously you're going to have different types of uh, output depending on which time zone you're in and when you're watching this video, right? So that's something that's fun. So maybe you can actually drop down a comment and maybe you can tell me which time zones you're watching this from. Maybe just return this value and type that in the comments. So the type of now, notice here, it's a double because this is interpreted as something numeric, okay? And when we look at the class of this object, the class of this object now is POSIX CT and POSIX T, which is just something that that's related to dates and times, and that's how it's stored. Okay, you can also try looking at date and systems date or systems time zone wherever you are. Okay. And also, if you are curious about what this means, POSIX CT is a widely used framework for representing dates and times, and each time is represented by the number of seconds that have passed between the time that you, which is now, and when you're running that R command, and 12 a.m. on January 1st, 1970. And that will be in Universal Time Coordinated, the UTC time zone. Okay, so to get that, to get the number of seconds that have elapsed between right now and that time, you can use the function unclass on now, and then it gives you this very large number, right? So that's about dates and times. Okay, now turning to factors, and this is, I think, the most important type of information that you encounter. I mean, all information is important, but I think this seems easy but can get complicated fairly quickly. So it's very important to learn this correctly. So we'll talk about factors. Factors are basically are objects that store categorical or qualitative information. So examples are sex, right? So you can have two types of values for sex, male or female, right? So there is a limited number of categories that you can have for this type of an object if it's a factor. Similarly, there could be race or ethnicity. There are only so many races or ethnicities. And similarly, the different types of college majors, for example, or different types of colleges in a university, right? So there's only limited type of this information, right? It's very different than having a numeric vector. So that's why we classify these as factors. And let's try to look at how do we create one, okay? So let's say we wanted to create an object called sex, which is a factor variable, okay? And this is how we create a factor variable, by using the factor command. And within that, within the parentheses, you're going to create a character vector, right? So here you can see that the first element is male, the second element is female, the third element is female, and the last element is male, okay? And you can obviously try to look at the type of object that this is. So this is going to be stored as an integer, even though this is a character, because this is stored as a factor, okay? And so you could try this out. When you look at the attributes of sex, it's going to tell you that there are only two levels, male and female, in that entire vector. Okay, so this is very useful. If you think about, if you have lots and lots of data and you had a particular column which is telling us about, let's say, race or ethnicity of all the people in that data set, then we can get all the levels by just by just using the attributes command on that particular variable. So it's very, very useful, very powerful, that without actually scanning and scrolling through different spreadsheets to find out what's going on, R can just tell us what are the different types of levels or different types of values that variable takes. Okay, and then finally, if you were to look at the class of sex, which we created, which was a factor, R is going to return factor over here. Okay, now there is a particular subset of factors which are called ordered factors. So these are nominal factors where order doesn't matter, right? You could have the first person is male here, the second person is female, let's say, third person is female, and fourth person is male. You can even change the ordering. You can put the fourth person first, etc. It's really not going to matter that much, right? As long as that information isn't changing. However, if we have ordered factors, ordering does matter. Okay, so let's try to look at what do we mean by that. Let's say you were rating a product, right? So you're a customer, and you're rating a product on a scale of 1 to 3. 1 means bad, 2 means okay, and 3 means good, right? Now, you could work directly with numbers because numbers also have meaning, but using factors is definitely more convenient. And you'll see, and you'll be probably convinced later on in other videos when we do some modeling, because we can attach labels to these outcomes. Okay, so let's try to create a ratings vector which just takes values between 1 and 3, right? So maybe this is sort of, think about this as representing that the first person in your data set gave that product a score of 3, right? So maybe they thought that product was good. And the next two gave it okay, which is just represented by the number 2. And then again, good, and then again, the last person said bad, okay? Now, if these numbers actually correspond to bad, okay, and good, then we can actually create a factor where R actually knows that bad is less than okay is less than good. Okay, so how do we do that? We can create another vector called ratings underscore F. And I'm just making this up because then this is telling us that this is actually a factor. We can use the factor command or function here. We can tell R that the first argument is this ratings vector that we had created initially, and we can give it labels. So we can say that the labels there are only 3 labels: bad, okay, and good. Okay, and we're going to write it in a particular order. We're going to start with, let's say, what 1 corresponds to, then what 2 corresponds to, and then what 3 corresponds to. And then we're going to tell R that ordered equals true. So we are emphasizing here that the ordering of these numbers matters, right? So if we take a look at what ratings underscore F is, it says the first value is good, which corresponds to 3. The next 2 are okay, which corresponds to these 2. Then the last 2 are good and bad, which correspond to 3 and 1, okay? And it's also telling you that levels, it's not just like male and female in the previous slide, but it is actually telling you that bad is less than okay is less than good, okay? So we'll try to exploit this later on, but for now, this is enough information. Now, let's try to understand how do we coerce different types of data that we see into other types of data. So what do I mean by that? Okay, so first we have to understand that we come across very many different types of data, And sometimes we want to coerce or we want to force R to understand that this is a single type of data. Okay. Now, there are some kind of conventions that R has. So if a character vector is present in an atomic vector, what R does is that it will convert everything else in the vector to character strings, right? So let's say you supplied, what does this mean? Let's take an example and understand. Let's say we created an object called 0, and that has different types of elements in it, right? So you can see that there is some text, there is a numeric value here, and there is some kind of logical value as well, okay? So if we look at the class of, I'm sorry, this should be 0 here, class of 0, it will return character here, okay? And if we look at if we create another type of object called 1, and 1 is, maybe the first element is 1 and the next element is true, then you can, then R, what R does is, if the vector creates logicals and numbers, then R will convert the logicals into numbers. So true will become 1, okay, and false becomes 0. So this is just a convention to remember that R will interpret true as 1 and false as 0. And so you can actually use the sum command to sum function to sum the different elements of 1. Okay, so here we get the answer is 2 because this is 1 plus 1. So that's what it is. Okay, you can also ask R explicitly to convert data from one type to another with the as dot functions. Okay, so here notice that if I want R to interpret the digit 1 as a character, I can use the as dot character function. If I want R to interpret 0 as a logical data, then I can use as dot logical. And if I would like to coerce true into being read as numeric, then I can use as dot numeric. So these are going to be very useful for us when we wrangle the data later on, okay? But it's good to know right now. Okay, now coming to sort of the last leg of this video, which is to deal with lists and data frames. So we'll start with lists. Lists are just a group of data that is sort of a one-dimensional set, okay? This is very similar to a to-do list that you create at work or school, okay? So maybe think about the different types of things you gotta do in a semester, right? Maybe there are different types of items on that list that differ in length, in their characteristic or type of activity that you have to do. And so you can club all those into a list. So list can basically group together our objects, and so basically you can group together different types of atomic vectors and even other lists. So here is one example I would like to give you. So let's say you're a college student and you created an R object called buy. Maybe this is your shopping list from the campus store, okay? So, I mean, even though these are expensive, we'll create that thinking that you might want to buy a sweatshirt from the campus store, or maybe pens from the campus store, right? So these are the two things that go into the buy vector. And then maybe you have some homework due and you're just taking, 3 types of classes. You have math classes, you have econ classes, and you have dance classes, right? You want to try to have some life. So you have dance classes as well. Okay, and then maybe there is an exams vector, which basically tells you that you may have 4 exams in that term or in that semester. So you can then create a to-do list, okay? So you can create a to-do list, I'm just calling it to-do, I love lists and I create many for my own work. And this is going to use the list function, okay? And then you can add a bunch of things in it, okay? So maybe by goes into it, which is this one. Homework goes into it, which is from those three departments. And then maybe, you don't need to create a vector for paying tuition. Maybe that's just something you have to do once. And then the last element here is exams. Okay, so that's what went into this list. And let's take a look at what does this even show us. So if we were to print this list, this is what shows up. So here is the first element in the list, and then the sub-elements from that first element of that list are sweatshirts and pens, okay? And this is the second element of the list, which is math, econ, and dance. And the third element is pay your tuition. And the fourth element is just a sequence going from 1 to 4. Okay, so now that we know this, now that we know how to create a list, which is, again, you can see this is of different lengths, right? This was of length 2. This was of length, this list was composed of vectors of different lengths. This is of length 1, this is of length 4, right? So you have all these different types of objects in that list. You can try to print the second element of the vector homework. And how do we do that? So the double bracket indexes that you see here, 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 and here, those tell you which element of the list is being requested, okay, or is being displayed. And then if you follow it by the single bracket, then you are telling R which sub-element do you want R to display. So if we did something like this, for example, to do, and we said double brackets, number 2 here, which corresponds to, if we go back here, this is corresponding to the second element, which is homework, right? So we are saying from homework, extract the second element. That was econ, right? So R returns the value econ because that was the second element, second sub-element of the second element in that list. Okay, so it's a sort of a mouthful here, but that's what this does. Okay, so the last thing we want to cover in this lab is our data frames. And these are the most useful and the most frequently encountered data types that you will see in this class. So what are data frames? These are just two-dimensional versions of a list, okay? This is, think about this as just like an Excel spreadsheet, for example, okay? So what it does is it groups vectors into a two-dimensional table, and think about each vector becomes a column in the table, and I'll show you an example. So the important thing to remember is that each column of a data frame can contain different types of data. But within a column, and this is important, within a column, every cell must be the same type of data. Okay, so let's take an example here. Okay. We want to make sure that each vector that we have in our data frame is of the same length. Okay, so this is very different than a list. A list could be of the different elements in a list could be of different lengths, but in a data frame we want to make sure that each vector is of the same length. Okay, so how do we do that? We use the data.frame function. So let's say we want to call our data frame df. Okay, so we are just giving it a name. You can call it whatever you like. So df is basically going to be this whole thing here. And let me explain what we're doing. So in parentheses after data frame, we are going to supply some data. okay, to this data frame. So the first column maybe is the name of the person, okay? So here we are going to write down some names of people, and we are going to also write down what type of exercise they like to do and how many times a week do they exercise. Okay, so here notice that the first vector is name, and notice here there's an equal to sign, that there's a slight difference in how you create a data frame. Generally, you will not be creating data frames, but you will be using data frames to do different things. However, you should know exactly how to do this because sometimes this is useful. So think about name as an object that stores all of these names, right? So we have Pavlina, Michael, Kwan, and Venu. And after that comma, which you see here, we are also going to write down their favorite exercise. So Pavlina likes walking, Michael likes weights, Kwan likes cycling, and Venu likes yoga. Okay, so the next thing after the comma here is the number of times they exercise in a week. So Pavlina does exercise 7 times, Michael does 3 times, and Kwan does 5 times, followed by Venu at 6 times. So you can take a look at the data frame by just typing DF. And notice this just looks like a little spreadsheet, you know, a very small spreadsheet where you have the name in the first column, exercise in the second column, and the number of times that people are exercising in the third column, okay? We'll talk about strings as factors later on, but now let's move on to the last thing here. So you can look at what is the type of object for the data frame. It's going to say that it is a list, but when you look at the class of DF, it's going to say that it's a data frame, okay? Now you have seen in the past that we can take a look at the structure of the data frame or any type of object or any kind of data object by using the command str, which stands for structure. And it's telling us that this is a data frame in which we have 4 observations because we had 4 people. We have 4 observations on the 3 variables. Okay, so the 3 variables are now listed: name, exercise, times. Okay, and it's telling us what type of vector each variable is. So name is a character vector, followed by exercise is also a character vector, and number of times of exercise in a week is a numeric vector, okay? Now, if you would like to coerce exercise to be a factor, you can do that pretty easily. You can say, let's take our data frame, use the $sign to get the exercise variable. Okay, so this $sign is just something like, you know, you are opening up, let's say the data frame was a cabinet and you are just reaching inside to get exercise because the data frame contains many different types of variables, including exercise. And so you're taking that, or you're storing it as that, and you're using the as.factor command on that same variable, okay? So when you look at the structure of data frame again, notice with as.factor here, which coerces R to read exercise as a factor and not as a character vector, we have now converted exercise into a factor which has 4 levels, okay? So here we can see that the 4 levels are cycling, walking, etc., right? And also it gives R also stores these internally as integers, and so it's giving you some values here, 2, 3, 1, and 4. And 2, 3, 1, and 4 are just because R sort of alphabetizes those. So 1 is corresponding to cycling, and you'll learn about this later because that starts with a C. So it's just alphabetizing these, and it's giving them these some values. So this is 1, followed by walking is 2, weights is 3, and yoga, which starts with Y, is 4. Okay, so that's it for this video, and I'll see you in the next one.